Very warm welcome to everyone, to SolarPower Europe members and guests to today's webinar. Today, we want to talk about our latest report, looking at solutions to mitigate critical cybersecurity risks. Why? It is clear that renewables are a vital element of Europe's future security strategy. Renewables are homegrown. They are helping to weaning us off dependencies on fossil fuels, where we can't control supply and are fully dependent on volatile prices. And a decentralized energy system is more difficult to attack than central units. In summer 2022, Solar saved Europe nearly 9 billion in avoided fossil fuel imports, just to give you also a figure. But Europe's energy system is also facing extraordinary challenges. Russian attack on Ukraine and supply disruptions. And just yesterday's blackout in Spain and Portugal showed that there are challenges we absolutely need to overcome as the consequences are detrimental. We've seen trains and flights stopped, people were not able to communicate anymore, traffic lights failed, hospitals operated on emergency mode. So these challenges have tested infrastructure resilience and exposed the urgent need for rethinking energy security and security at large in Europe. SolarPower Europe's vision is very clear. We want to build a secure, competitive, and climate-neutral Europe powered by renewables, powered by solar in particular. And before we get started, I would like to highlight a couple of key elements that need to align. First, we need to change clearly the parameters of energy security that we used to have in Europe. Traditionally, we focused on diversification of fossil fuel supplies. The new focus absolutely has to be on electrification powered by abundant European renewables. Second, we need to speed up electrification. That is clear. We need to electrify transport, electrify heating, electrify industry. Medium temperature heating can be electrified, very low and medium temperature heating can be electrified very quickly. So electrification needs to be the key focus. But with electrification, we also need to modernize infrastructure and increase flexibility. We need to expand digitalized grids and improve cross-border interconnections. That is has also been shown yesterday. We need to make sure to increase flexibility with a special focus on battery storage. Not just it increases the security of system operations. Might have helped in Spain and Portugal in the last couple of hours if there would have been more battery storage. But it also improves the business case for solar to grow faster, to provide all these benefits. And all of that needs to be acknowledged in the EU's grid package, which needs to be complemented by a flexibility package. And we need a storage action plan alongside a strong electrification action plan. And last but not least, and the topic of today is cybersecurity. A new energy security challenge that we need to provide solutions to. As energy systems decentralize and digitalize, cybersecurity becomes critical. SolarPower Europe's cybersecurity vision is we need to strengthen device security and its communication with the cloud, and we need to secure the supply chain. All of that will be presented to you in a minute by DNV, where we had a very good collaboration with to provide the report that we are going to launch today and we're going to discuss today. For me, the final message that I want to pass on to you is, again, solar PV is a proven enabler of European resilience. And together, we must continue building a Europe where every megawatt of solar strengthens peace, strengthens the resilience of Europe, strengthens security, prosperity, with more competitiveness and security. Thanks very much again for joining us. I'm now handing over to Jan Ossenberg. Jan Ossenberg is our head of system integration, who will take us through the rest of the webinar. Jan, the floor is yours.
Thank you very much, Walburga. Welcome to all the participants. Great that you have joined us so numerously today. So now let's dive deeper into the risk analysis, into the solutions that we propose, and the implications of these solutions and the analysis. I'm going to be the moderator of today's webinar. First, we're going to see the presentation of the report, which was developed by DNV. And then we're going to have a panel discussion with a few distinguished speakers, which I'm going to introduce in a minute. So, and after that, we're going to have a Q&A. So whenever you have questions, please write them in the chat. We keep track of them so that we can address them after the panel discussion. Now, let's start right into it with the presentation of the results by Ryan Davidson. Ryan Davidson is the principal engineer for electric grid cybersecurity at DNV. He has a background in both power system protections and control and industrial cybersecurity. He really he was the ideal developer of this report. We found the perfect match. He focused also on grid automation, the secure integration of DERs, distributed energy resources, cybersecurity solutions for grid operators, renewable energy systems, and actively contributes to the development of industry standards, including IEEE 1547.3, and advances the trainings and awareness initiatives in the DNV cyber arena. Ryan, before we go into the presentation, what's your reading on yesterday's blackout in Spain and Portugal and in parts of France? How do you assess the situation?
Yeah, thank you, Jan, for the great introduction and question as well. It's very relevant for today's discussion, I think. So first of all, we've seen in a lot of the different reports that very early on there was some reports of this being a cyber event, and then some other things coming up. But the reality is the power grid as a whole is a quite large, quite complex system. And we need to balance the generation with the distribution because it's used as it's created. And otherwise we need to store that. And so we have this very large, complex system where whenever there's a large change in that system, a transient, it could lead to some cascading outages, and there's thousands of different things that could lead to that. So at the moment, really all we can do is kind of sit and wait to find out the result of all the different investigations and troubleshooting that's going to go into this event. But really it's too soon right now to tell or speculate on what the actual cause of that was.
Okay, thanks a lot, Ryan. So we're looking forward to the reports that are coming out in the next weeks. I'll give you the floor for the presentation.
All right. Yeah, so thank you again. So today I will be presenting the work that we've done over the past 4 months in cooperation with SolarPower Europe. There was a lot of input from number of different colleagues across DNV in areas of power system planning and calculations for the grid, as well as market analysis for the solar market. And a lot of input as well through some of the different SolarPower Europe members, TSOs, DSOs, manufacturers, developers, and so on. So a lot of effort went into this. Before I go into some of the findings, I want to set the stage a little bit for what's sort of happening and where we're at now. And I think there's no surprise here, Walburga already touched on it a bit, that the grid is evolving and we're going from a fossil fuel and coal-based infrastructure, generation infrastructure, to something more electrified, more digitally connected, and a bit more complex, but also much more efficient and more sustainable. And we're really just at sort of a tipping point for that. There's still a lot of room to grow. DNV does every year an energy transition report, as many other organizations do as well, to forecast what that generation is going to look like over the coming couple decades. And over the next 25 years, there's going to be even more significant expansion within the solar infrastructure. So depending on where you're at in the world, in 2050, you're likely to see anywhere from 1/3 to half of the grid being supported by solar. And so it's absolutely critical that early on in this journey that we're on, we make sure that that infrastructure is secure, that it's controllable and resilient, so that we have that we're able to maintain the secure infrastructure. And one other thing that's changing as well, and Wilberger already touched on that, is that we are going from a centralized generation system where we had a very large plant that then distributed, much like the trunk of a tree, through large power lines that then trickled down to the lower voltages to the residences and end users. We now have a much more decentralized, so it's more complex, but also much more resilient in terms of having fewer single points of vulnerability, these large transformers, large generation plants. So it's much more distributed. Now, simultaneously, we have a change in cybersecurity. We've seen that in the past, cyber has been very much focused on traditional energy infrastructure. And the evolution that we're seeing is that there's a sharp increase in the frequency of successful attacks on energy infrastructure. In a report from Energy Cert, they're a Danish organization, the same year that the attack was on 22 different, that was on the energy infrastructure in Denmark. They did this report as well. They handled that quite well. Nothing was, there was no actual physical impact of that. But there was an attack, they recognized it quickly and were able to remediate that. And that's the case in many of these scenarios. Because of the fact that we've seen the increase in attacks, and as a result, the European Union has taken quite sweeping regulatory changes and has introduced a lot of very great, regulation that has helped really drive a overall improvement in the cyber maturity. So that's not just in this industry, in the energy industry, but in all critical infrastructure we see that taking place. So we have these two parallel paths, right? So we have the energy transition on one side and cybersecurity and resiliency on the other side, but they're not really truly parallel, and we can take advantage of that by leveraging one for the other. So I mentioned that we have this decentralized concept with the solar infrastructure and with the DER, distributed energy resources. And you see in actual conflict, generally, what's more effective is just to bomb a substation, or even in smaller attacks, protesters lighting fires to cables, for example. It's easier to have a larger impact when we have a centralized infrastructure with large single points of vulnerability. But we need to make sure of is that with this decentralized infrastructure, we maintain that digitally as well, so that we still have the secure, decentralized digital infrastructure that also controls and supports that. So now looking into the report and how we got to the recommendations that we have to manage that. So we started with looking at the threats. And if you want to have some sort of cyber physical impact on the grid, we see that there's roughly two main ways that you can do that, either directly through the infrastructure, so something along the lines of exploiting a vulnerability and getting unauthorized access to something, or you can exploit the supply chain, so going through an organization, for example, a manufacturer, through a third party who has access to equipment such as developers, installers, and so on and so forth. And we also broke that down further to look at if there was a compromise of the organization, or if the organization was cooperating with the attacker, as the approach for solving those threats is different. And then after we started to dig deeper into the threats and analyzing those, we also saw that the solutions for those vary quite significantly as well, whether you look at utility scale solar versus rooftop solar. So the approaches to solving that also varies. But then after looking at the threats and looking at the different players in the market, we wanted to understand how likely is it that you could actually have an impact on the grid? Could you see something like what happened in Portugal, Spain, and France? Could that be caused by solar? And more specifically, could that be caused by a cyber attack through solar? So we did what we thought made sense was to go to the European grid models through SOE and run some analysis on that. So we did exactly that. We took the model, we worked with them to do some tuning of that model so that it was purpose fit for the specific scenario. And then we ran some simulations. And what we see is that, not surprisingly, the frequency of the grid is actually quite stable, even with the measured results of a large loss of generation in France in 2022 of a little more than 2.5 gigawatts. There was only a slight decrease in frequency, nowhere near the actual point where we would have to start calling in special reserves and so on. So it's quite stable. And what this means is that if there was an accidental loss of a significant amount of solar, then we would likely be able to maintain grid stability, and we wouldn't see any potential for cascading outages. However, when we look at the voltage for this, and even at the 2-3 gigawatt range, if there's an intentional manipulation of reactive power output, there is a potential that you could see significant grid transients for voltage, which could trigger nearby protective devices for either other generation or other substations. And that does raise some alarms. So theoretically, it could be possible for an intentional attack to have some impact on the grid. So we know what's possible, and we want to look at how do we prevent this? So how can we make sure that this doesn't actually happen? And we identified two major points that would help us get to that point. One, so we want to define a guideline, essentially a how-to guide for end-to-end security for the PV infrastructure. That would be aligned with the Cyber Resiliency Act, so then testing could be done with industry-specific guidance to certify those products. And then there would also be an element for technical barriers or a security layer that could then lead into the second point of controlling remote access. So if there's a desire to have a independent and resilient energy infrastructure for Europe, then we need to make sure that we can manage that remote access from within the EU and secure jurisdictions. And we base that off of GDPR as sort of the guideline for what that looks like. And that includes remote access for system changes. So that's changing the configurations and parameters or the output of the system. That's also delayed remote access through software updates. And then finally, the storage of device information and other sensitive data related to that. So looking at that a little bit deeper, so the first step there, the cybersecurity standard, that would be kind of an end-to-end how-to guide, which doesn't just include the inverter, but also the management platforms, the cloud integration, and all the communications between those, so that then we can look at holistically that entire value chain to make sure that that's secure. And this would not be something that has to be developed from scratch, right? There's already a significant amount of research out there and a significant amount of work out there that starts to go in this direction, but we need to bring all those together to have a guideline that's purpose-built for this function. And then within that, it would also include alignment with the CRA, as well as the recommendations for some potential secure remote management strategies. Now, the remote access, some would say that this is something that's very difficult to do, but it's not impossible. And it's actually already happening across the industry. There's some utilities that have already started to implement this. And I like to use the example also of online banking on your cell phone. You're able to access all of your financial resources from a small metal thing that lives in your pocket. So it's possible to have distributed security across all these different devices. And what that would essentially look like is having this intermediate security layer, so a communications gateway that's managed by a regulated party. So what would essentially be somewhat of an operator of critical infrastructure. And then they would be responsible for ensuring that that communication is secure and hardened against cyber threats. So that would give us a few different options for the DSO or the local grid operator, where they would not only have a more secure channel for communications with that, where we can separate critical and non-critical communications. But it would also give them the ability to have more control over that system as well. So then there's the option for things like a secure remote restoration or being able to control those devices to maintain the grid stability. But in order to also do that, we don't need to just secure the communications, but also the delayed process as well through the software. So that would include things like a software integrity plan to make sure that the software is developed securely. There could also be trusted execution environments, which essentially lock down and keep those critical operations safe so that they're secure from other tampering. So that is the idea of how we mitigate those risks and what that looks like from start to finish. So when we look at all the threats, we did the analysis, and unmitigated risk, of course, across the board is fairly high. That's generally the case with unmitigated risks. That's why we mitigate them. We looked at the existing policies that are in place, NIS2, CRA, and others, and we see that it does have a measurable impact on the various threats, but specifically within the energy infrastructure or within the DER space and solar, for example, there's still some gaps, but with these additional recommendations from this report, we think those different threats could then all be brought to a low. And so the roadmap for how to realize that, how do we get to that? Well, first we need the guideline. That's sort of the basis for this. So how do you secure end-to-end this infrastructure with different things like password security, secure by default inverters, making sure that the communications to cloud is secure. We need to lay all that out end-to-end. And then with that, we see the most direct route and the quickest route is through the network code for cybersecurity, while seeing that the provisioning for DER as a critical generation process would then allow us to do things through supply chain requirements for DER, where then we could, through contracts either for financial aid or through interconnection with TSOs or DSOs or with the energy markets, there could be requirements to have the infrastructure tested against this guideline or evaluated against it to ensure that it meets all of the requirements for this minimum level of security. There's some intermediate and future steps to this as well. We would also like to see once the Cyber Resiliency Act, all the vendors are compliant with that. I believe that's towards the end of 2027. It would be great to see that inverters are listed as critical products similar to smart metering. And then if necessary, there could also be potentially dedicated fast track processes depending on how far we're able to get through the network code for cybersecurity. And the final state, the end state that would be great to see is that the primary legislation would then focus not just on the traditional and the infrastructure that dominates the grid right now, but also the future looking infrastructure that is very heavily reliant on all these different digital and distributed resources like battery storage, PV, controllable loads, EV charging, and so on. And with that, I will hand it back to you, Jan.
Thank you very much, Ryan, for this presentation. Quite clear, you indicated the 3 gigawatt a loss in generation is quite simple to counter. But when actually the 3 gigawatts are used to change voltage levels in the grid, they would have a significant impact. Also to address one of the questions in the chat, because we found that the 3 gigawatts actually sufficient in this in this possible scenario. That's why we also didn't model higher than that. But also quite clear on your recommendations that we need a vertical standard for PV and at the same time limit remote control of inverters to the European Union and secure legislations. So thanks for that. Now let's move to the panel discussion. So we have 3 distinguished guests on top of Ryan. We have Felipe Castro Barrigon, who's a policy officer in the European Commission in the area of energy security. He's focusing on cybersecurity, and he holds a master's degree in telecommunication engineering and in business administration. We also have Jörg Ebel from IBC Solar, a distributor and developer of PV installations. He is the Vice President for Corporate Affairs at IBC Solar. He serves as the President of the German Solar Association, BSW, and is a board member of SolarPower Europe. Last but not least, we have Eric Quiring, who's a public affairs leader at SMA, the global inverter manufacturer. He oversees the company's engagement with policy makers and stakeholders, has a background as a trained electrician, as well as political science and public affairs. Welcome to this panel discussion. So to start off, Philippe, let's start with you. Could you outline the EU's existing cybersecurity framework, and what is your assessment of Ryan's presentation and the report?
Thank you, Jan. So indeed, I start by the second part. No, is the first assessment I would say I like it a lot. This presentation and the report, because it does not only focus on one aspect of that, for example, devices, no, like an inverter, but it looks at it more broadly and looks at the supply chain and different processes, industrial processes that are around solar installations. So I think this is very important. Not to just look to one aspect of the broad and more complex problem of cybersecurity around industrial installations, in this case about solar. No? So in that sense, I think it's a very good contribution, and I'm looking forward to read it in the detail actually. Now, the second, your first question about the framework. So I would like to describe a bit today's situation in the EU. Is that we have at least two levels of legislations that are applicable to cybersecurity, and in particular in the sector of energy and electricity. No? One is the EU level, so directives, regulations that are adopted by the Council of or the Parliament and the Parliament, sorry, mostly proposed by the European Commission. So this we have the example of NIS2, for example, is probably the main one. The CRA, you mentioned also, Ryan, on the Cyber Resilience Act, the DORA regulation for financial services. We have also mentioned in the presentation the network code on cybersecurity for electricity cross-border flows. So these, as you know, directives in the EU jargon are EU legislative texts that need to be transposed at national level. So there are national laws that implement the EU legislation. Other, like the regulations, are directly applicable. So, for example, the network code is a delegated regulation and it applies directly in the member states. So this is the EU level, and as I said, as a consequence of that, in some cases, there are national legislations implementing the directives, but there are also other national laws that are applicable in each of the member states on the domain of cybersecurity. So this makes a bit of a, I would say, complex framework, but when you look individually, and this is also the result of experts discussing and drafting those legislation all over Europe and adopting them later on, each of them covers a different aspect of what we were discussing and what Ryan presented as well, no? In terms of devices and products, in terms of services, in terms of as well of supply chain, and this creates a bit current legislation framework that you were mentioning.
Thank you very much. Thank you very much, Philippe. So I see there's already a lot of work going on. Now let's turn to the manufacturers of the inverter. Eric, cybersecurity is in the public discourse for quite some time now. How do your customers, how do the PV installers react? Have you seen this impact the procurement and the choice on the market?
Yeah, thank you, Jan, for the question. First of all, thank you for the report and that you cover this topic, because it's very important to continue the deployment of solar and the growth of the industry. The discussed in the past was always linked to controllability and how the remote control via internet on the solar power plant really works. And this is only one, as we saw in the report, one of many different risks we see. And there are many sub-courses, but there's not only one solution you can match to this risk. So it's what we see. It's not that the installers fear the connection of the internet or fear interoperability, but we see that they're getting much more awareness of cybersecurity, but also awareness of the product itself. So the inverter maybe for some installer used to be just a commodity converter of power, but now everybody understands that the inverter is really the heart or the brain of the power plant, and it's very important to choose the inverter. And this is something we see in the market, and I think everything starts with the awareness, and now installer asking for the tools they need to get more secure power generation.
Interesting. So there's quite a maturation happening in the market. Thanks a lot. Turning to you, Jörg. You are a board member of SolarPower Europe. You are closely involved in the development of the project. How did you react? What were your findings of the report?
Yes, thank you, Jan, and a warm welcome to everybody in the webinar. The high interest demonstrates that this is a very important topic SolarPower Europe has on its agenda. As the source for Europe, solar and the solar industry is always aware that we have to be very crucial on every security topic. And this is not something new or something starting just today, but this is a ground task we have since years, and SolarPower Europe is working hard on, for example, on the safety of hardware and other issues, and so is cybersecurity. And I think it's very important that we start to look at cybersecurity not only now, but at every time, and we do this. And this report is just a glance at the given situation, because security always is a process. And another thing I would like to point out is that this report is, as security is a process, and we have to work not only once at it, but continuously. There will follow a second part of the report looking at the measures the member states have undertaken, because this report focuses on the EU level, but we will get the full picture when we look at measures of member states. For example, Germany, with the CRITIS regulation, has a very tight and intense security net against every kind of cybersecurity. And maybe in the second report, we have the opportunity to demonstrate best practice measures. So this is not the beginning point, and it's not the end, but it's one point of our continuous work on security issues.
Thanks a lot, Jörg, for putting this into context, both on the broader picture of energy security work, but also on the importance of the national level that is, of course, often developing at different pace than the European level. Now, turning back to the European level, Philippe, how do you assess the existing cybersecurity framework in terms of the gaps that we have found in the report? Where do you see, as the European Commission, need to catch up and to update the existing legislation to address risks?
Okay, thank you. So I think we need also to differentiate two levels. One is the existence and comprehensiveness of existing legislation, and the second part is the implementation of this existing legislation, and how gaps may come from the legislation itself or from the implementation. No? I think when we look at the existing framework, there is a relative, I would say, common understanding that it's relatively comprehensive. So the different type of mechanisms and instruments that exist, for example, taking NIS2, CRA, Cyber Solidarity Act, the network code at EU level, but then complemented with the national laws. If you look inside, you can find more or less all of the elements that, for example, Ryan was describing in this presentation, no? From device cybersecurity to supply chain, remote access, basic controls, basic hygiene, all that somehow is there, no? Now, it's relatively recent. Implementation is ongoing. For example, NIS 2 came into force, and 2023 is being transposed. Some member states have not even yet transposed the law. Similarly, for CRA, will take some time. Network code came into force last year. It's starting implementation now. So we need to see what is inside compared to what can be done, how it will be done, and at current state, in 2025, was the level of implementation. So, in my view, and I say this also looking into what we receive from the experts in the industry and many of you today in the panel, but also I guess in the audience, have participated in the drafting and adoption of those legislations. I think we have, I think, a common consensus that it's a time for implementation, that we need to put in place what exists, and then see if there are gaps, either because they are not addressed in the legislation or because the implementation of that legislations are either too difficult or not appropriate. This we need to evaluate, and there are mechanisms for that. But in principle, I would say that we have a fairly comprehensive framework, and it's, for me, time for implementation. And this is the difficult part. I think for me, this is really where engineers also need to be there and to make sure that it's implemented the way it needs to be in each of the sectors, subsectors, and in particular, for example, in solar, in the solar type of infrastructure and the architectures that we have today in the EU.
Okay, thanks a lot, Felipe. Eric, we hear that implementation of what's already there is now a key focus. A lot of elements are already covered. How does SMA include this into their offering and into their device setup?
Yes, the aggregated or connected solutions we see in the solar field, there was initially not really covered by the policy design of centralized power plant. Now the regulators came up and tried to tackle those challenges, and I wouldn't say this is a market failure or something. It's just the development of solar was so quick, and to the great acceptance of solar, and also with the push of digitalization, we see more aggregated solution. And at SMA, we see those challenges since a bit of time. And of course, we work after international standards and norms, but also what we do at corporate level, that we train employees, just like basically train employees, start with awareness, monitoring the system, helping the customers to improve their own security level on individual level, but also on a corporate level. And of course, the product security is very important, and design the security of the product, and to start with the design of the security, do risk assessments. And in the worst case scenario, I mean, the last days we saw some of the worst case scenario in Spain. We provide solution that helps you, like in an emergency situation, that you get even electricity from your inverter during a blackout, or for utilities, that we provide solution with black start capabilities and functions that you can start the grid also from electric batteries. So these are just examples that show that the topic is very aware at SMA, and we're working on this topic for a very long time and try to help stabilizing the grid and the power supply in Europe.
Okay, thanks for outlining the what you're doing to protect, but then also how inverters are already helping to secure power supply for those in times of a blackout. Now, Ryan, that was the product level. Now let's talk more about geopolitics. We hear a lot about China and the issue that there's an exposure to the European power grid to Chinese inverters. What conclusions do you draw from the report with regards to this question?
Yeah, thanks for the question, Jan. Absolutely. So, yeah, there has been a lot of media attention, and also even in the regulatory space, some of the governments of different member states have drafted regulation to this effect or have made public statements. But this all hinges on the assumption that the Chinese government would actually try to use one of their inverter manufacturers to carry out an attack. And going through this analysis, what we see is we believe that to be a very unlikely scenario for a couple of different reasons. One would be this would essentially be economic suicide for any manufacturer that would participate in this and support this. And it also, generally for these manufacturers, they oppose the economic strategy of China at the moment and the sort of aggressive nature. But also for China, there would be, and for Europe, there would be pretty significant geopolitical implications of an attack like this. It's sort of bordering on this gray area of an act of war, an act of aggression. So that would certainly stress geopolitical tensions quite significantly. So what we can say at the moment in the current landscape, it doesn't seem like this is a likely scenario. But of course, we can't predict the future. We're not geopolitical experts. We just look at the technical feasibility. And what we do see is it is technically possible through these vendors. And it's also, they have the capacity. It's gone past those thresholds for having enough capacity to have an impact. So the capability is there. But it's extremely unlikely that capability would be used. But regardless, if you still look at that as a threat, we have ways to address that. We still have ways to mitigate that threat through the right regulation or engaging stakeholders to implement these security levels, this intermediate security level, for example. But to take a step back, that's not actually even the main threat that we look at and the main focus of this overall report. Rather, it's more so the general cyber maturity of the infrastructure and of the industry as a whole. So what we don't want to see is scenarios where the maturity of one organization is low enough that they could be compromised by a less resource, less skilled hacker than a nation state threat, for example. And what we see across the board is most of the major players very seriously. They understand that if they have a significant incident, they're likely going to be testifying and be on the hook for pretty significant damages for a large grid outage. So they have very strong cybersecurity programs. The development of their infrastructure is quite strong, but there still are a lot of smaller organizations, local stakeholders and startups that don't have these same resources and the same understanding. So what we want to see is this baseline guide and then the enforcement of that to make sure that all stakeholders within the industry have that same base level of cyber maturity.
Okay, so I hear a lot that we have to raise the general cybersecurity level to make sure that all manufacturers and service providers have the strong security levels that some already have. Now let's turn a little bit more to the actual development of the devices and the development of devices on the market. Jörg, IBC Solar is a retailer and a developer, installer of rooftop PV installations. How has your strategy shifted in response to increased cybersecurity fears in the past years?
Yeah, IBC Solar, with its more than 40 years experience, has always had an eye, better say, two eyes on security issues. When we started in the early 80s as a company, we were literally producing our own inverters before we get SMA to be launched. So we have a lot of experience. The other thing is that we have one of Europe's largest installer networks. And to us, our first question and issue is to care for intact and high quality products for our customers. And one thing I want to stress out is that the end consumers' products are not affected by these questions directly. They are affected indirect if systems get attacked. but the systems as such are not affected. That's one point. The other point is there were storage systems already mentioned, and IBC is the company which was the very first mover of battery. We were the first company bringing battery systems into the market, and we are one of the companies behind the success that Germany already has a load of gigawatt hours of battery capacities installed. Why do I mention this? I personally was launching the Solar Supports Ukraine initiative. And we have a lot of experience coming from there in Ukraine, because we provide solar systems with large batteries and black start ability. And we can see that with this battery in a situation of a broken grid system, you can act very quickly and respond very quick to that. And that, to us, this is one point of our strategy. The others, of course, to be an integrated member of SolarPower Europe, BSW, BDEW, and several other associations working hard on cybersecurity issues and supporting the efforts to raise the cybersecurity from day to day.
Okay, very clear, Jörg. I see you're taking the step forward. You're using it as an opportunity also to make the grid more resilient by using batteries, which of course also going to be used for demand response, helping the decarbonization pathway. So let's now turn to the questions from the audience. We have quite a few questions. I would like to start with a question to Ryan on standards. There's a question from Nuaim Suiki. Sorry for the pronunciation if it's not correct. Referring to the existing legislation. UL 2947, IEEE 1547.3. How do our recommendations what is the difference between our recommendations and the existing standards and guidelines out there?
Yeah, so fantastic question. I touched on that kind of a little bit in the presentation, but not in detail. But what we essentially did, so I was involved in the development of 1547.3, so I'm pretty well familiar with that. And we did a review of some of the others, like UL 2941. That's not yet published, but essentially at that point, which is very specific to certification of inverters for cybersecurity. And of course, there's NARC standards as well. But when we look at those, they cover a lot of ground, but none of them match exactly with what we need in terms of having a guide that then systems can be evaluated against. They tend to have either a slightly different focus, or there's specific elements of them that don't quite fit. For example, with the UL 2941, there's no requirement for third-party certification, which we think for critical infrastructure that makes up such a large percentage of the generation in the future, that should be something that's absolutely required. So we did look at those. With the development of the guideline, we would want to be able to base that off of existing work. So doing a sort of gap analysis between those and comparing them all together. So it's not necessarily a replacement for those, but collecting them together and then coming up with something that's purpose-built for exactly what we need here in Europe.
Thanks a lot, Ryan. We will make sure to reach out to DG Connect and DG NR so that there's also a European push for such an addition and complementing the existing standards out there. I would like to turn to a question from Uri Sado and Stefano Gambro about the existing devices. Again to you, Ryan. How likely do you see that our recommendations solve the issue with the existing infrastructure that we have?
Yeah, so that was one question and one point of focus during the development of this report. And because although we're at sort of the earlier stages, not the early, but earlier stages of this development, there's already a significant amount of solar installed. And so we do have to have some sort of mechanism for addressing existing installations. And what we see most likely and most effective mechanism there would be some sort of intermediate security layer, that technical barrier that then is able to put the control back into a regulated party's hands, such as an aggregator, a VPP, a virtual power plant, for example. And we already see this being done across the industry. There's different utilities that have secure communication gateways already at all the installations, even at residential, for example, in Australia. Here in Germany, that's also something that's being established through some different legislation and the smart metering infrastructure with control boxes for like heat pumps and loads. But then also the possibility to use that same infrastructure for the secure control of legacy solar infrastructure as well. So we see that as the most likely scenario, and there's already some installations out there in the field that show that this is a good path forward.
Clear. Thanks a lot, Ryan. Now, Felipe, there are also two questions for you on what do you see as the most suitable tools to address the challenges? We proposed the NCCS, the Network Code for Cybersecurity, to leverage that, because it's an ongoing process that we can use, which can be faster, of course. And then, so what's your assessment of the situations? Which tool do you most likely see? Maybe also referring to the initiatives that you already have ongoing or that you already have planned in the European Commission, and then what would be the timeline that you see as relevant for until such improvements actually hit the ground?
Okay, so in terms of which are the most suitable, I think, again, we cannot just say one of them is more suitable than the others, because each of them addresses a different aspect, no? If we look, for example, to topics like information sharing, and this was mentioned as well before, no? Then probably NIS2 is a very important one. It sets up all the CERTs network and the way that they should communicate with each other and with the entity. So this is, for that, a very important case. For device security, CRA should be now in the future, now, because it's still starting, no, a good tool in principle if well implemented, no. If we talk about industrial processes in the electricity, and especially in the cross-border flow domain, then of course the network code, as you mentioned, I think it can be a very good tool because it gives a lot of flexibility, let's say, to regularly identify which are those critical processes, no? And this is, for me, actually one of the main things that we need to look at, and you mentioned gaps before as well, is that in order to address a cybersecurity issue, like any other, I would say, engineering problem, we need to know it well. We need to understand very well what is that process, how it is operated, and there are possibly, for many of those processes, many different ways of operating them in the different entities. So the risk assessment process to identify which are those critical process, high impact processes, for example, in network code, the risk methodology, the risk execution, the risk assessment execution, for me is the most important part. And there we may see also today that the maturity is different in entities, in experts, and sometimes we may have better or worse risk assessments, and therefore the consequence of that is that the type of measures that you can put may be more or less suitable for that, no? So this would be a bit my view on what are the critical elements, and this is across the, I would say, different type of instruments we have, no? In terms of timeline that you mentioned, I think also this takes time. So we see that implementation of the different legislation takes time, but it's not because the legislation only takes time, but it's also the maturity. Also before Ryan was mentioning about skills and awareness. All this takes time, and I don't think we can assume or we can pretend that this can be very much shortened, but the good news, I would say, here is that we see more and more that all actors around in the industry, electricity, but also in cybersecurity in general, is getting more and more traction. And I think the gap in skills and awareness, it's each time smaller. So this is also, I think, the good news on this aspect now.
Thanks a lot, Felipe, for putting into perspective the pathway for legislation and market-driven adoption. Also, a question going in a similar direction from Nuaim Suiki, to you, Ryan, mostly. What can an installer already do today to help the customers that are maybe aware of the situation or afraid and want to make sure that their data is protected and their processes are protected? What can you do as an installer already today to address this?
Great question. So there's different things that different groups along the supply chain can do. Ideally, we wouldn't have to rely on the homeowner to take steps, but it's still important that they do that, or not just homeowner, but also for commercial and industrial installations. So from an installer perspective, they can do certain things like making sure that there's no default passwords, and just basic cybersecurity hygiene is maintained, to make sure that there's some sort of access control, that you can't connect to this infrastructure through the plain internet, that there's VPNs and secure communications used. And then also from the end user perspective, they're going to have applications on their cell phone or on their computer for some of these comfort services for monitoring and collecting data. They want to make sure that they use unique passwords for that. If they can set up this infrastructure on a guest network instead of having that on their same home private network, and just very basic general cybersecurity hygiene steps would be a great first step. So becoming aware and knowing what the basics are, I think, is the best advice.
Thanks a lot. I think that's the perfect ending for this discussion. Really focus. We talk about all these highly sophisticated discussions, but at the end, it's also just about setting a secure password, making sure it's not Sun123. So thanks a lot, Ryan. Thank you very much, Felipe, Jörg, and Eric, and Walburga for your presentation. Thank you very much, Ryan, and the team of DNV for developing this amazing report. So we heard quite clearly that PV is not only an essential pillar of energy security, making sure that we replace the dependency on fossil fuels, be it from Russia or the United States, with the sun and the wind, which will blow forever or shine forever. But then, of course, we have to make sure cybersecurity is ensured. So what we see today is PV installations already benefit energy security, but the energy cybersecurity framework is evolving, and we have to make sure we keep track to this development. As concrete immediate steps is the call to develop a harmonized standard, a baseline for cybersecurity for PV inverters, and making sure to limit remote controls to secure jurisdictions. In SolarPower Europe, we are going to continue on this discussion. We will make sure to advocate for electrification, for flexibility in the power grid, but then, of course, also for cybersecurity, making sure that these solutions actually end up in the network code for cybersecurity. And in 3 years from now, we don't have to worry about this so much anymore. As the next steps for us, we would like to see you, the participants, at Intersolar, which is going to be next week, the big trade fair for the PV industry. We're going to host a session on inverter remote controllability, which is open to everyone. Ryan is going to be there, going to present the report. We're going to have a representative of the European Commission. We're going to have plenty of other experts there, and really, we want to hear from you. What do you think about this challenge? What are your considerations? How would you like to go about if you are an installer? What are your reflections, and how will this change your procurement and development? So to go into a discussion with you about this topic. And last but not least, join SolarPower Europe. We have a digitalization work stream where we discuss these points day in and day out. You will have access to a great network of experts, including Ryan, so that you are always top informed, not only on the European legislation, but also hearing what your competitors are doing and what are the options to advance you. So thanks a lot for all the engagement, for all the questions in the report, and I look forward to turning this call into real action. So have a good rest of the day. Bye bye.